You're on.
I'm on. Thank you, Tim. Hi, everybody. It's so good to be back with you all on a Sunday night. We've had a real good week around here, and we just had a really fun meeting trying to get organized for the next few months. Let me tell you what we're going to be doing for the next few months here, because that's always important. I think that you guys know what we're about. Um, Tonight, you can see that we've got Warren back. Warren is back here to tell us about easy peasy Hubble palette processing. You know, it seems strange to me. He was going to call it secrets of Hubble palettes or something like that. But we're not very good at keeping secrets here in the astroimaging world. It seems like everybody's got a YouTube out about the secrets of so and so and such and such. Anyway, Warren's here tonight, and you're going to be able to ask him any questions you've got as he proceeds. Tom Malmary is coming. He's next week. He's coming from the Juno team, and they've got some fantastical pictures of taken by the spacecraft as it went past that big planet and the moons and things like that. So I think you'll get a big kick out of that. Brian Cogdill's going to come and tell us about putting your scope at a remote observatory facility. Conrad's going to come, and we've got a whole lot of other people coming. As you can see, we're pretty well full up, getting up until November. But you know me. We always want more people to help volunteer. We figure that, there's a whole lot of people that know about astroimaging, and there's a whole lot of people who have things that they can share with people. And even if the program you're thinking of doing has been done by somebody else, you probably have a way to do it that's just a little bit easier, a little bit simpler, or for some dumb reason or another, just makes more sense to somebody out there. So please go ahead and hit the contact button when you can and give us your name. Tell us what you'd like to present about. That's how we get a lot of our presenters. So please do all that. Now, we've got to reorganize our website, frankly. We were talking about that because we've had Patrick come. Oops, just a minute. Yeah, our website looks different. And let me see. Uh-oh, it's gone. What I was going to show you was our YouTube site. YouTube, the Astro Imaging channel. And if it comes up properly, it's still updating and refreshing. Yeah, okay. It shows us what's the current show and a couple of the live streams that are coming up. And we've reorganized it so that it now shows us the past live streams. So you can see that, well, if you remember old Bob ZEQ here last week, 1.7 people have watched all or part of that show since then. And so you can go back and look at all our old shows. And you can look, but you can also see all of our new uploads. We've been making a real effort with Patrick Spencer. He's been coming in and he's been snipping out the baloney of the talk and some of the questions and things like that of a lot of our past shows. What we're trying to do is package some of the real dense material into 10 to 20 minute chunks that you can come and get. And we've got to do some stuff to get it organized for you and stuff like that. And so far it's been called tutorials and clips, and now they're being called shorts. And someday we'll figure it all out, hopefully in the next few months, and we'll get all that to you. But take advantage of these. You can see that they've been very popular, 600 shows in the last 4 days, 600 viewing in the last 4 days. And so anyway, there's lots of things for you to see over here. We are making some changes as we go along. The one thing you have to remember about, this is where I want to go. The one thing you have to remember about our YouTube channel, the Astroimaging channel, is that we're different than everybody else in that everybody else puts together a show, practices it up, polishes it up, and puts it out there. You can't ask them questions as they're going along. You can't find out from other people what's happening with them. You can't clarify what these guys are saying. It's only on the Astroimaging channel that you get a chance to do that by typing in over here all the questions that you might have and just add to it. Plus, it's kind of like your Astroimaging club, a virtual club where you can get together and say, hi, Ray. Hey, John at Astro. How you doing? Marsha. Hello. How you doing, Marsha? So enjoy yourself. That's what we are on the Astroimaging channel. And one person that's been with an Astroimaging channel for like ever, he was in some of the early shows and he's come back every so often, is Warren Keller. Warren's a master of PixInsight. He has written inside PixInsight books, updated them regularly. I think nearly everybody who uses the program has something to say. I'm going to turn this show over to Warren. I'm going to stop sharing. Warren, you ready to go?
Yes, thank you, Alex.
Okay, Warren, take it off.
Yeah, I'm going to share my screen. And there we go. Should be good. Everybody see that okay?
Yep.
So we're not doing this tonight, but I wanted to show you a little bit of fun with the new James Webb Space Telescope data on NGC 3132. I found it very similar to narrowband processing. It's the first pro data I'd actually ever messed with. I was really happy about that. And if you're interested in doing that, also, I'll tell you that our friend Nico Carver at Nebula Photos is a great place to start. He's mostly Photoshop based and processes the data in Photoshop. So if you're a PixInsight person, you'll still find it very valuable for how to navigate the archive and how to get the data. And then once you get that data, he kind of gives some clues about what filters you're actually looking for too. And what I found really useful was this this map of how to map that in near infrared data. So by all means, have fun with that. It was really, really cool. Tonight, we're going to look at Eta Carina. Most people are saying Carina these days. I kind of stand by Carina and Carinae. This data is courtesy of Telescope Live. So I want to thank Marco and Mentore and Alex, different Alex, for that. I don't thank this Alex McConaughey for anything. Other Alex,
hey.
just teasing, your bosom buddy, and you know that. And my uncle. And so I'm going to be doing some tutorials with those guys at Telescope Live as well. So thanks very much for this data. So we called it easy peasy. Those of you that know me, kind of follow me, maybe you kind of know I'm a galaxy guy. Love those galaxies. Love those southern sky galaxies, and obviously everything that's up there. But I don't do a ton of narrowband. But I feel like I've done some nice, successful images with it, and so I wouldn't hold myself out to be an expert. But the thing that I do see on the web that kind of bothers me is really super complicated processes where folks are maybe dancing between PixInsight and Photoshop and back to PixInsight. Another thing that really drives me crazy and I don't really understand is, and I would never do it with broadband, and I'd really try to avoid it with narrowband as well, is just kind of indiscriminately going in with, say, histogram transformation and making very arbitrary stretches of each individual channel. And then when you put together, I think you have more correction that you might need to do. And again, you're just kind of eyeballing things. So this may not work for you every time, but it does really seem to do a good job in a very easy way most of the time with Hubble palette data. When you have significant sulfur 2, oxygen 3 data to contribute, usually HA is going to be really strong for any emission nebula, right? But you want to have enough of those other guys to make for an interesting color palette. So I just start with good old channel combination, right? And of course, I love my little icon set that I've been adding to, evolving with, and changing since the very beginning, but something that we've always offered either through the book inside PixInsight, which incidentally is still a great book, but it's long in the tooth. You know, PixInsight is always changing. It's very dynamic. And there are some, in fact, I had a conversation with a really nice fellow at Springer last week, who's the new astronomy editor over there, Michael Mimoni. And, you know, just kind of talking about the ability to correct some stuff that's so out of date now. But in the print world, it's really hard to do that. And that's why, you know, we've concentrated more on, for instance, mastersofpixinsight.com, where we can really provide the latest and greatest information there. But I digress. So yeah, but I'm happy to send people my current icon set for an email to either myself or Astro Imaging channel. Again, it's something we've given away along the way. So you know you can store settings in these icons, which is why they're so helpful. And you'll notice that typically I'm looking for an _R, an _G, an _B image in the RGB default color workspace, and I'd be boom, ready to channel combine them. But in this case, that's not going to work, right? So it's SHO, right? And we map sulfur 2S to the red channel. And of course, I renamed these images to keep them nice, easy names. You can double click there on the View Identifier tab to keep nice short names, make it easy to navigate when you're processing. H, hydrogen alpha, right? By far the strongest signal, again, in emission nebulae, at least. And you'll notice it's mapped to green, right? And that's a reason why a lot of us get kind of stopped in our tracks when we see a very green dominant image and then have to work extra hard to try to get a nice color balance on it. Finally, if you can follow along in the alphabet with me, SHO is going to be oxygen 3, and that's going to get mapped to blue. And as we know, oxygen 3 in reality is teal. So it's 50% blue and 50% green. So this is really a false color palette, right? It's mapped color. It's very arbitrary. And I think it was discovered that this particular combination, and to a lesser degree HOS, which is the Canada, France, Hawaii telescope palette, you know, yielded a very pretty, beautiful image, also scientifically valid. So we know with 3 images in there, anything that's going to batch with more than one process, we're going to apply global with an F6. And this is our SHO. I can go ahead and rename that. And how do we see this image? Well, a few different ways. We can Control or Command A to work with the screen transfer function. If you happen to have the screen transfer function toolbar out, you'll have the famous radioactive icons, and they interface with the STF as well. But let's open the STF itself and let's track that view, lock on that, make sure we're locked on the right image, right? And you'll notice that by default, so let me put a auto stretch on. This would be a boosted auto stretch. I shift clicked there. And it is as predicted, a rather hideous green mess. And by default, the STF links the channels. And as you'll notice, if you look at the shadow slider there on the left and the midtone slider there in the middle, right? The highlight slider is hiding over there on the right edge. You can just see that little caret. But there's I call it a ham-fisted stretch. It's forcing all 3 of those channels with the same stretch. And what did I say a moment ago, right? In an emission nebula, the hydrogen alpha is going to be the strongest signal, and it's mapped to green. So, hey, no surprise that that's what it looks like. So remember I mentioned I see a lot of kind of arbitrary stretching going on, and kind of, you know, just hit or miss type of thing. Well, this is so simple, it's ridiculous, and nobody really seems to have noticed it much. Just like we unlink channels to get a better view at broadband color before we've done things like background modelization, right? ABE, DBE, before we've done color calibration. We typically unlink the channels, right? Because unlinking will provide a optimal stretch to each one of the channels. And so, dang, look at that. You're already 75% of the way there to where you're probably going to want to go simply by doing that. But before we perform a permanent stretch, let's use the crop tool to get rid of our borders. Good old crop. Some of you know me pretty well. I'm a real fuss budget, a little bit of a lunatic minimalist perfectionist. So I don't like to move my icons around. So I found that if you right click on them and say launch, you're not constantly shifting those icons and having to reload them. Again, if you're a Looney Tune like I am. But let's bring this up. And I think we had some bad edge. Oops, let's reset. I dragged it accidentally. And I think we had some bad edge over here. Let's zoom in a little bit. Remember the cursor, if whatever's right under the cursor will stay under the cursor. And I'm just trying to avoid that little green edge there. I think we're okay. Maybe, yeah, a little bit more there. And come over here. And then I think we can come back. You know, one expression that I love by my friend and peer Adam Block was making every pixel count. I thought that was one of the most quotable things that he'd ever said. And that's really what it's all about, right? We work hard to acquire data. And you know, maybe you don't have to be this fastidious, but you don't want to lose anything. You don't want to leave anything on the table. So we know with the dynamic processes, we need to click the check mark to execute. Sounds like a firing squad. And that looks good. You can click the little fit to view there, and that'll make that fit to window. So let's see. So background modelization, right? DBE would be my first line of defense. ABE would be a second choice. But guess what? From Chile in an Atacama sky with narrowband, there won't be any gradient here. There won't be any multiplicative, additive gradients. And as far as multiplicative, well, it's obviously been beautifully flat corrected. So in this particular case, we can skip background modelization. One thing you can do is you can kind of relink the channels up again and just grab one of the midtone sliders, is what I would do. And of course, it's not going to go very perfectly evenly there, but you know, if everything seems to kind of saturate at a very even level, that's kind of a good tell that you probably don't have any gradient worth going after in this. So I am going to do some linear noise reduction because it's a great opportunity, right? Before we stretch, before we delinearize in PI speak, to get rid of a good deal, lion's share of the noise. Right now, this has got some great signal on it, for sure. If we look close enough, you know, we'll see a little bit of chromatic, a little bit of what I call salt and pepper noise in there. So yeah, it's worth doing. Now, it's kind of funny. I had a talk at the last Advanced Imaging Conference called Riding the Wave, which was about wavelets. And when I picked that topic and started to prepare, wavelets, at least for the linear space, multi-scale linear transform, right? And I'll open that real quick, was the way to go. Took a little bit to learn, did a good job, a really good job if you took the time. But tonight I'm going to show you a tool that I've embraced, and I know that Ron Breacher, my teaching partner at Masters of PixInsight, have embraced, and it's, you know, Russ Croman's noise exterminator from rcastro.com. Is it a commercial for us? No. Yeah, it is, but not because Russ needs to get rich and not because I'm getting any money from it, but it's so good and it's so easy to use that I'm going to use it tonight for noise reduction. And if somebody wants to raise a hand or shake a finger or yell, we can go into multi-scale linear transform and see what I would do with that. But as many of us are probably aware, Russ is at now full-time development on his astronomy tools, having become semi-retired at his semiconductor career. And he's learned over the past year and change machine learning, under the blanket of artificial intelligence. We have machine learning. You hear about training neural networks, and similar to like Topaz AI denoise, this is getting trained on specifically the noise that we see in astro images. So it knows what it's looking for and it knows how to get rid of it. And that's pretty darn impressive. And honestly, so easy to use. And I'm all for ease. If it's that good, if it's better than, I'm all for ease. I don't think things need to be super complicated. And that's part of what we're trying to accomplish tonight anyway. So being linear data, you want to make sure that your linear box is checked. Early on, he detected a little bit of a bug that if a background wasn't neutralized, that it didn't work as well. But I find most of the time that that's not the case. And remember, we haven't stretched this, so it really would be okay if we saw that it wasn't being as effective as it could be. We could neutralize the background, even though good luck finding a truly color neutral part in this background, except maybe this blackest black, let's say, something like that. And then applying noise exterminator and then balancing the color back again. But I think this works fine. I'll tell you what, this 0.9 is the default, and more times than not, that's exactly where I feel like I want to be. If you, I don't want to say like noise, but if you don't dislike noise as much as I do, you might find that 0.8, 0.85 will give you maybe a little bit less plastic look. And I hate plastic, but I like smooth. And so I'm most of the time amazingly just right there at 0.9 is about perfect. What it also has is basically an unsharp masking feature, but it's noise aware. It's noise aware. So you can find that although the default is 0.15, you'll find, I think, that you can leave it most of the time, unless you're dealing with really noisy data and you just want to concentrate totally on the noise reduction. 0.15, 0.25 just gives a little bit of edge enhancement and doesn't really harm anything. So with all of that said, I'm going to apply this. And of course, every time you purchase, and you get an email when he has done more training and there's a new AI, a new increased machine learning that you can download and install. So let's apply this. I suppose if we have any pressing questions while this runs, it might take a little bit. We can do that. But
well, there is a question hanging out there. So why don't I just
sure
ask it now when it's taking its few seconds? Josh asks, what's the difference between additive and multiplication gradients?
Yeah.
And how do you identify which is which?
Yeah, good question. So multiplicative are the easier ones to deal with. They're really rooted in the optical system itself. And the most classic example of a multiplicative gradient is vignetting. Right? Dark fall off in the corners and bright hot spots in certain systems in the center. And so the multiplicative thing there is that it's, and I'm not a mathematician, guys. Many of you know that it's, it's, what is it? Cosine of the fourth order failure. So it's a predictable equation that says the further off axis it goes, there's going to be a predictable light fall off away from the center, away from axis, right? And we correct those with flats, and we can correct them with DBE, for instance, or ABE if we didn't use flats, or if the flats didn't do a great job. Additive are the PITA. They're the big pain, because basically they get added in. As long as that shutter is open, they're creeping in. They're getting added, whether it's light pollution, whether it's, local light trespass, whether it's errant lights in the observatory, whatever it is, it's getting added. And we can't predict how much, right, is getting in there. So that's when DBE really earns its keep, if you will, subtracting out that additive gradient, just like it would divide out the residual vignetting. So hopefully that makes sense.
Yes, there was another question, actually a comment. People are interested in your set of icons.
Okay.
So could we put up a way that they can get it? Maybe we could put it up on YouTube.
Yeah, absolutely. Rather than Mr. Minimalist getting bombed with emails, I'll send them to Alex, and you guys will post it. Right? Does that sound good?
Yeah. Well, let's see, my mic's on, right? Yeah. I think we can get them off the website, right?
Yeah. We'll talk about it after. We'll make sure.
Okay, we'll talk about it. And the other question was, instead of using LRGB combined, you use the channel combined, I think.
Well, I used a combination, right? Because I wasn't dealing with a luminance image, right?
Okay.
And
And
just let me add a comment on an emission nebula like this, where it fills the entire image. I would say good luck figuring out if there is a gradient or if isn't there a gradient. As you said,
Well,
where would you start and where would the background be, except perhaps in that dark area? The other thing is, I was a TGV noise reduction user for years, and I was skeptical about his noise exterminator until I started to use it.
right.
And I am also a convert.
Yeah, it's silly. I mean, TGV probably less than MLT, multi-scale linear, which we would be doing now in the linear, is probably harder to really understand and dial in, right? But they're both a bit challenging. I mean, once you get it, you get it. But as Eric is saying, he and I and many people are saying, you know what, this just does a better job with a lot less headache.
Right.
And so, it's not super expensive. And if you own a product of Russ's already, like Gradient Exterminator and Star Shrink for Photoshop, or Star Exterminator for PI, I think it's like still $40, and it's well worth the money. So let's see. So we'll zoom in here a little bit and see if we can see a difference with before. Got to get a little closer, I think. And after and before. After, you see that? A little bit of sharpening on the stars, which we could have chosen not to do a little detail enhancement. Lost a little bit of the saturation there, I see. But the magenta stars, not a big deal. And remember, we didn't use a mask. So again, you could use a mask if you notice detail getting eaten away. There's less and less chance of that happening as Russ continues to develop this. But even now, I see very little erosion of detail without a mask, because again, this knows the profile. It knows what that noise looks like, and it knows what it's going after. So good stuff. So at that point, I would be ready to delinearize, to stretch. And there's an extra step in this, perhaps. So if there's histogram transformation, we'll point it to the SHO image, right? You can see that histogram over there. So if, and I'm sure most of us know this, if we're linked, when we drag and drop that transfer curve over. And I lied. It decided to be, oh, I know what it is. Okay, because we're not, all right, so let's do it for real. Okay, sorry. All right, so channels are linked. We go back to the green monster, right? If I was to bring over that transfer curve in the RGB combined red, green, blue channel, you would see the transfer curve, right? But this isn't what I want. And I just feel like this is such an easy approach that I'll sacrifice not being able to see that curve. And here's what I mean. If I unlink the channels and again, do a boosted auto stretch on that, now drag and drop, well, where's the curve? Well, these guys are moving forward, aren't they? They're getting developed. That's getting a stretch. So where's the curve? It's hiding in the individual red, green, and blue channels. That's where it is, right? Because we brought over independent stretches. Now, at this point, even though I see that there's some dead space there before the toe of the histogram, I don't want to go into each individual channel and, magnify them and drag the shadow sliders up to the toes and all of that. I don't want to mess with that. I'd rather do a second step and refine that once I've stretched the image, once I've delinearized. I'll keep Juan happy, delinearized the image, okay? So I'm going to cancel our stretch, right? Turn the monitor off. And we could open a real-time preview if we wanted to. We could manipulate further, which in broadband I certainly do. I try to make the best stretch I possibly can at that point. But with this, I'm just going to do that. And then again, if I want to refine this now I can work in the combined RGB K channel if I thought I wanted to close that gap a little bit and get a little more contrast in there. So, that's okay, I think. And I'm a lot more cavalier when it comes to narrowband. I'm kind of a total fuss budget when it comes to broadband, really try to get those colors accurate and, color calibration, all that stuff. But narrowband, let's face it, it's mapped color, it's false color. And I don't think we have to drive ourselves crazy. It's about making it look pretty and also hopefully having a little bit of scientific, validity there. So let's see. So after the stretch, you could consider another round of noise exterminator in the nonlinear space. And remember, you would just want to deselect linear and maybe lower that amount at that point. But I think we're in good shape. And I don't think we need to worry about it. So the next thing I think we ought to do is deal with the Magenta Stars. Magenta doesn't bother me as much as it does some people. It's pretty intense here, but it doesn't drive me crazy. Some people do the, RGB, red, green, blue, broadband replacement of stars. I always think it's a little bit weird. I mean, it looks good and, you can do that. That's great. But it is a little bit odd. Oh, I want my stars to have real color. But hey, it works, whatever works, right? Sometimes, though, the images really have a preponderance of magenta in them in addition to the stars. And I can see, some in here, I would say, particularly in these corners. So I'm going to use a script. And this script is under utilities, as many of them are, and it is correct magenta stars. Now, some of you have seen the inversion trick using SCNR, and this is exactly what that does. Remember, most of the scripts call on processes in the background, and so this one indeed does do that. It'll invert so that the magenta is green, and that it'll use SCNR in the green mode to destroy the magenta, and then it inverts it back again. I want you to look at this name here, Roberto Sartori, right? That's Robix. So this was, as far as I know, Rob's very first contribution to PI, and now he is a co-developer, I believe full-time with Juan Canejero. So that's Roberto. You have the ability to to lower the amount or raise the amount. I find like I like to keep a little magenta in there. I think it kind of goes pretty with the cyans and stuff, but you can kill it pretty much totally. Notice that you can use a mask. So you could use a star mask if you just wanted to deal with the stars. And in this case, I think it's going to work out pretty well, getting rid of a little bit of the magenta in the corners there, and also with the stars. So let's see what happens. So there's a bunch of inversion. And of course, being a script, I'm locked out. I can't zoom in. I can't see the result. So I'll just have to close it. And we can look at the before. Oops, we have to go through those several steps of inversion. So how about we do this and right click on the View Identifier tab, load the SHO's history. And so we'll go from the state we're in now to there. So that's a pretty nice reduction. We could go further if we wanted to, but I think for our purposes, that's fine. I might have even left a little bit more in there. I don't know. That's me. Okay, so at that point, my feeling is this is a great time to do StarNet, to do star removal, I should say, right? Don't have to. Stars make very small contribution in this image. We could easily use a star mask while we're doing a little bit of contrast enhancement, perhaps sharpening to the nebula itself. But you know, why not? I mean, the star removal tools have made it so easy. And of course, if your goal ultimately is not to have any stars in it, to do a starless narrowband presentation, which can look great, really like that, take the stars out, because we've reduced the noise and we've reduced the magenta chromaticity. So to me, this is a good time to take the stars out. And I'm going to use StarNet 2, which, you know, is the later and greater version by Nikita Misura, the developer of the original StarNet, and really what got Russ Croman on the path of thinking about and learning machine learning for his Star Exterminator. StarNet 2 is really good. It's so much better than the original StarNet, and I think it's about on par with the 4Pay Star Exterminator at this point. And the only thing I can say is knowing a little bit about Nikita's life. He's a young guy. He just got his doctorate. He started out on his first big career. And so we probably won't see additions to StarNet 2 for a long time, if possibly ever. And of course, Russ is going to continue to develop the Star Exterminator. So let's run StarNet 2, default stride of 256. We want to create the star mask. It's never been a star mask. It's not a great star mask. It's the stars themselves. It's the star contribution itself. So it's a little bit of a misnomer there. He's got a couple of I don't know, I think almost superfluous choices here. One is to double to 2x upsample. What he says is that if you see artifacts in what he describes as the tight, bright stars, I've never seen them. You can try upsampling and before you run, and then you can sample back to where it was if you want to do that. I've not seen those artifacts. And the linear data, and Nikita himself would say it's pretty weird. If you were insistent about removing the stars on a linear image, it stretches the image, removes the stars, and then stretches it again. And that's a little bit destructive and weird. So let's apply this, and then we'll see if Eric's got any more questions for us.
I don't see any over here. Let me take a quick look. No, I don't see anything.
That's good.
Yeah, well, no,
we like that.
That's a nice looking image.
While we're waiting for this, Warren, when we were practicing the other day, you mentioned that you had a project going this week. 125 people showed up, and what was that about while we're waiting for this to happen?
Well, you know, my longtime partner, Pete Prue in Buffalo, New York, we were together with image processing for astrophotography, IP for AP.com. And when we lost the Adobe Business Catalyst host of IP for AP, we'd already been getting quite successful with masters of PixInsight.com, affectionately called MOP, the MOP shop. And so we nested IP for AP.com into MOP, masterpixinsight.com. We're all about live workshops there. You know, Ron Breacher is now our partner too, Dr. Ron. Ron and I were doing live PI workshops around the country before COVID. And when COVID hit, it was Pete's idea to do that virtually. So we do live workshops several times a month, different formats, and they get recorded, and customers, clients can stream them at their leisure, whether they attend live or not. We also have some great sponsors there, some great door prizes. So we did a deep dive the other night in weighted batch pre-processing, and obviously a lot of hunger there. And we had 256 registrants, which was way over, you know, anything we'd ever had before. So we thank everybody for their support if they're doing the mop shop thing now.
Okay, looks like you're ready to go.
Yep. So let's take the stretch off of this. So it's kind of odd. It puts a stretch on that coming out of there, and you think, oh my God, what did it do to the stars? Well, you know, the stars are still okay. Star mask, whatever you want to call it. So we'll tuck this over here and get back to our image. And now it's like, you know, it's field day time, right? We can have at, you know, do your worst, as Monty Python once says. I mean, without the stars there, you can sharpen, you can increase contrast, increase color saturation, and it really makes it very easy. I'm a color guy. I love color. And so I tend to do color kind of early, just to convince myself that I've got what's going to add up to a pretty image, right? And that really counts in in broadband, when sometimes you have this wonderful luminance image, but your color just didn't do well, you know, whatever it is, and you go, oh man, that's really disappointing. So I'm just a little bit antsy about that, and I always try to hit it with some color. Now this has already got lots of color, doesn't it? And if I open up my curves transformation, you'll notice the purple curve there. And that's because that's the saturation channel, right? There's the purple there. So we're looking at the saturation channel. And if you don't like looking at multiple curves, you can always deselect here. So you'll only see the curve in the channel that you're actually in. So I am going to open a real-time preview, and you notice that my icon is actually stored with a saturation curve there. If you don't see any control points along the way, that's because I've got one hiding right down here, 750. It's like bumped right up against the anchor point, right? So that's too much for sure. 375 would be half of that. I could take a good deal more than that. How about 500? That's kind of nice, maybe, for some of us. Some people would go less. It is a matter of taste, and we get to do pretty much whatever we want, as long as we're happy. And of course, you have the ability to take the more saturated pixels, and let's measure some of those. Like maybe these are the more saturated pixels, and you see where the vertical line is falling on the curve in curves transformation. So we could actually dial down the more saturated pixels a little bit if we wanted to. You can put multiple control points, but I keep it simple. And this would be the before and the after, and the before and the after. And we know that when we enhance sharpness and contrast, which is going to affect the lightness channel, the grayscale channel, combination of the three color channels, that's going to tend to draw our eye away from color saturation. And there's a good chance that this will actually become a little dilute when we finish, enhancing the contrast and sharpness. So let's do this for an initial hit. I think that's fine. I bet you I'm going to want a little bit more. And I don't think it matters a great deal what order we do this in. Sharpening or contrast. Basically, sharpening is small scale contrast enhancement, and contrast is larger scale sharpening, basically, right? I do have a mask, I believe, from my last run. And okay, so this is a Synthel. And so let me just mention, I didn't use a synthetic luminance in this processing. I didn't. But that's a good concept to just touch on. Many of you have heard about the concept of pseudo-luminance or synthetic luminance, and some people prefer to do their sharpening and their contrast work to the grayscale image. And it's the same data, but it's combined in a little bit different way. And not to digress too much, but basically you would want to take your 3 files, your SHO, you'd want to go back into image integration. You'd probably want to use your strong hydrogen alpha image as the reference. And you would make a grayscale image of either just HA or HA and 03. Of course, normally the S2 is pretty weak. And you could use that as a pseudo-luminance and actually lay it over this with an RGB combination. But what I wanted was, and I guess it doesn't, I guess it looks like I actually don't have that, is an L mask. And so if I'm sharpening, I don't know, again, in this case, the signal's so good, there's detail to sharpen pretty much everywhere. I think we've really handled the noise quite well. So I'm not even going to bother with a mask. I'm going to open MMT, multi-scale median transform for my sharpening. MLT is perfectly fine for sharpening. It's great. I generally always used MLT. I kind of got convinced recently that, you know, since MMT is not subject to ringing at all, that maybe it's a little bit a better choice. But let's open a real-time preview. And let's zoom into an area that's got some significant detail there. Not doing any sharpening in the first smallest scale layer, right? Don't want to enhance noise there. Just a little bit of, and let me show you that, just the bias is increased just a teeny bit for the second and third layers. And let's see if we can see the difference there. It's subtle, but you can see it, right? If you look at this detail and this detail, and you could play with that to your heart's content. I'm usually somewhere between 0.025, let's say, and 0.05. But subtle's the key, and I think that's okay for our purposes here. We are trying to keep it easy peasy, and I know we don't have all night either. And again, I wouldn't worry about the order of color saturation or sharpening or contrast enhancement. I really don't think it matters. It's iterative. You do a little bit of this, oops, now you need a little bit more of that kind of a thing. I like color, so like I showed you, I generally start with color. LHE, local histogram equalization, a wonderful, easy way to enhance contrast. At this setting, the contrast limit, I would be applying 1.5 times the contrast. Sometimes I'm double at 2, but more times than not, I'm at 1.5. This is not a wavelet tool, but like Photoshop users would know pixel radius, it's very similar to that, the kernel radius. How many pixels are we looking at for comparison? This is pretty small, 25, and then look at that, very, very small amounts. So once again, we do have a real-time preview. We can take a look there. I'll warn you that there is a little bit of a bug that I talked to the guys about, and you'll get an over exaggeration when you first get in there. And it's a little bit fussy, and sometimes it really over exaggerates. But it seems like it settles down when you go into the when you expand the window into the max. So before and after, and let's see, so see that? Again, subtle, your taste, whatever you want to do. I'm generally between, I see a difference at 0.12, 0.15, 0.18 is generally what I need. And you can see that's pretty extreme there. So how about we split the difference a little bit? Ron always says, if you can see what I did too much. I'm a little bit more in your face than he is, but I think that's a good adage too. And so we can apply, now to get back to your original view, either here or with the navigation arrows, or you can just return to the one-to-one. And we can apply, if we apply this, the real-time preview can stay open. It doesn't matter. It'll go to the active image, although it always makes me a little safer, feel better about applying directly to an image so I know where I'm pointing to. And local histogram equalization. Again, this is giving us an exaggerated view. It's only this tool with real-time preview. I would then go to larger scales. I like to double a lot of the time. Could try 50, and we get in contrast enhancement in larger scales. Can you see those bigger areas of nebulosity getting affected? We could get in there again, and you can control or command click drag to do that, or you can also use this little icon here when you want to zoom into a real-time preview. So that's a little bit much, I think, for me. Let's take it to 0.12. I might go a little bit more than that. 0.15. I think that's okay. Let's do that. You don't have to close the real-time preview, but it goes back to the one-to-one zoom every time, and that annoys me a little bit. Okay, and then finally I'll see, so you can go as high as 200. It's recommended. Generally, if you're doing some large scales, you might want to be around 100 or 150. And people that have heard me talk before, I've got this left and right brain thing. It's like my right brain wants to see the visual effect and see what's going on, but I always kind of try to justify it with, they call it Warren's rules of halvesies, right? I'm 25, I'm 50, I'm 100. I sneak up on solutions by kind of halving things. I'm weird, arbitrary numbers just kind of make me nervous or something. But whatever works for you. And I've had people that say, no, I really like that, Warren. That makes sense to me. And so again, larger scales, I'll generally be doing multiple passes with LHE. It's one of the easiest way to build contrast, and I think I like that fine. And so I'm going to go back to curves. Let's talk about that in a little bit more detail. So you don't have to. You can do, one channel at a time, but just be aware. Again, you can select to see more than one channel or just the channel that you're in. But curves has the ability to increase color saturation in the S channel or the C channel, which is in the lab mode, the colorfulness component. You've also got access to the red, green, and blue channels. Suppose this was really green and you weren't liking it. And speaking of that, we talked about SCNR in regard to the magenta. But notice I didn't use SCNR to kill green. And, we're of the opinion that keep your green around a little bit. Don't be so much in a hurry to just extinguish it, because look at how, I don't like that classic blue and gold I like it, the classic blue and gold SHO, but I like the variegation in these different colors, a little bit of cyans, even a little bit of green. That doesn't bother me. And so if you extinguish that, you just don't have that around to play with after the fact. But you could do, for instance, a color saturation boost again, along with a contrast type of curve. So let's do this. This is going to be too much color. I did it on purpose. Let's reset the tool. And so it's not doing anything, but I take that back. I want to reopen my tool. And this time I'm going to kill just my saturation curve with this little red X and go over to the lightness. And you'll notice Weird Warren, he's got a little anchor point here toward the shadows and toward the midtones and toward the highlights. And so we've got our real-time preview. What if we took a measurement like there in the darkest part of the image and kind of darken that up a little bit, and maybe either that or boosted a little bit of contrast there in the mids. I think that's kind of fine. And then while we're here, if we wanted to, we could add more color saturation. But I want to get into the U channel. And in the past, I would have, and if you read the book, talked more about the color mask script by Rick Stevenson, created several color range masks and adjusted with individual curves to dial down greens and increase reds and stuff and the yellows, but really found, along with Ron, that the U channel works great for this. You can put some control points to lock the curve down. And we got a real-time preview open here. Watch what happens when I kind of move those yellows to red. So that might be a bit much, but I'm going to exaggerate a little bit so you see that. And so that's a great way to do that. And then you can also kind of just experiment, like in here, with your greens and your blues. That'll get you more of a bluish, almost purple. This will get you more of a cyan. I kind of like pretty much right where we are. And again, it's very taste oriented. Going back to lightness here, maybe I want a little bit less of that contrast because I thought it really looked really good when we started with it. And I think I'm happy with that. So I'm applying 2 channels, right? And you'll see the 2 different curves there. And we'll do that. And there's a wonderful little script called Dark Structure Enhance, also in Utilities. And I will typically change the 5x5 B3 spline to the linear interpolation 3x3 because I think it does a better job on fine detail. And this script does not like masks. It creates its own mask, of which you can extract it if you want for those dark areas. But it will fail if you have a mask in place. And I generally find the preset to be too much. Let's try it at 0.2. Never went over 1 iteration. And this will enhance those dark structures a little bit. Now, this does have a tendency to put black over color. So let's say, so you see that? Right here is kind of nice. A little bit of extra contrast enhancement too. And keep it light, because what you'll find, and particularly with broadband like galaxies or dust lanes or dust in a nebulous field, if they're nice and brown, chocolatey brown, whatever, ruddier, this is going to have a tendency to just make those black. So enhance it lightly so you don't lose that nice color there. And honestly, at that point, I think we're ready to add the stars back in if we wanted to. And we're going to use good old pixel math You know, again, many of you have been with me and know I'm not a math guy. I'm not a pixel math whiz. There are some pixel math whizzes out there that you definitely want to check out. But I find I can do most of what I'm trying to accomplish with the processes and the scripts. And I can certainly add, divide, subtract, and multiply and make pixel math work fine for me. And guess what? There's people out there, great resources that offer much more complex. Ron is great. Ron Breacher that I teach with, he's great. There's some people that are even beyond that with some very complex expressions that can solve some, you know, some potential problems. We want to simply add the SHO, which is the image we're working on, with our so-called star mask. That's it. And in a case like this, don't even have to worry about rescaling because there's not going to be anything bright enough to exceed the 1.0 pure white scale. You could click it. It's not going to do any harm. We do want to replace, I want to replace the target image. There's no point in me making a new one. And that should do a great job of adding those back. If I felt like that was too much contribution, I could do something like 0.75 asterisk for time, so 3/4 of the star contribution. I find anything less really makes for an unnatural look. I think that's a little bit unnatural. So let's back up with a Control Z. Let's go to let's go 0.8, see how that does. And that looks more natural. And other than the stuff I would want to do for sharing, pretty much done. I would use the ICC profile transformation instance and SHO and just make sure that I'm in the sRGB working space. I am. That's my color settings and global settings is set for that. But before you publish, especially for the web, JPEG or printing, you know, make sure you want to be in the sRGB IEC profile. You just simply apply that pretty much at defaults. And at that point, we're ready to save as a TIFF, as a JPEG. We can resize here. I still value Photoshop a lot. I generally pop into Photoshop and do just a little bit of enhancement. Nothing standing out to me here, but most images I do. And so typically I'm resizing there. I'm saving my JPEGs there in my final TIFF. So that's what I've got. If we've got any questions.
There's been a lot of discussion over on YouTube.
Okay.
But mostly I think people are just watching and really interested in your process.
As long as the pitchforks aren't.
No, it's all positive comments here.
Excellent. Very good.
The Chandrasekhar asked about, you know, how is this Hubble palette, et cetera, and a couple of people have chipped in their answers, and it's basically an awful lot of what you just showed us as far as the Hubble palette goes is actually a lot of the same things one would be doing in RGB, LRGB, to enhance the details and things like that. It's just you start with the different color sets mapped to different colors.
Well, I think that the big difference is once you do that mapping, you got to get away from the green by balancing those histograms in one way or another to get the kind of image that Warren has up here now. I guess my only comment, it's not really a question, is in the Hubble palette images, I think what I try to do is get all the way from the kind of reds all the way to the purples, going over the entire spectrum and not just having, you know, the orange blue kind of image. Now, I don't know if there's any, you know, standard for that, but I think the more colors you get represented on the image, the more interesting it
Yeah,
is to the
I agree.
viewer.
I mean, don't get me wrong. We had Peter Jenkins to Advanced Imaging to do the presentation, and I love Peter's work. And he sticks with the classic blue and gold SHO and does terrific work. I like this. Again, you've got some greens, cyans, blues, browns, yellows, oranges, and so I like it. And again, whatever works for the processor.
Yeah, and I would put a big X through SCNR.
You would say not to use it.
Oh, absolutely not. I mean, that green is part of the image.
Right. I agree. It can be very pretty, and it's once you kill that, and that was something that a lot of us would do early on. Oh, get rid of that green. You don't take it into the stretch, and then you don't have the ability to do anything with it after you.
Yeah, I think we're hung up on no green stars.
Right. I think we'd agree there. Yeah.
Okay, where are we? My own.
And I'll just throw one more thing out there. There's always talk about color calibrating narrowband data. I mean, they even took the time to build in this color narrowband working mode into photometric color calibration. And frankly, it just doesn't make sense to me, and it's not worth doing to me. You don't have any broadband stars to base that determination on. So easy peasy.
Easy peasy.
Putting in pie.
Particularly if you've got Warren color skills, they're easy peasy. So thank you very much, Warren, for being here tonight and for leading us through that. If you could stop sharing, please.
Yeah, my great pleasure. Really enjoyed it. I hope everybody or most folks did as well. And hope to talk to you again soon.
Can you tell us how people can obtain the action image action icon set?
Yeah, well, we said that we would.
You're going to send me a link, and what I will do is add it to the comments on the YouTube show. Would that be okay?
Yeah. Can you load files?
We don't have a website facility for doing that easily.
Yeah, but I mean here in the chat, there's no way.
If you send me the link to it, I could.
But I'm in the actual file into a chat window. Like I can do that in Skype, for instance.
I don't think Google Meet does that.
Okay, all right, we'll figure it out, folks. We'll get it to you.
Okay. Yeah. Thank you, Warren, for being here. I know that I use my action sets. I modify them from what I got from you and, reorganize them and things like that. So, okay. Next week, we're going to Jupiter. And I hope everybody wants to come along because there's some really fantastic pictures out of Jupiter. I will not be here probably. I will be on an airplane going to see my kids over in the Czech Republic. And then the next week I'll be in the pub. My son owns a pub. He owns a couple of pubs in the Czech Republic. Yeah, and then I got to go. So I'll be back in a little bit. But you are in very, very, very good hands. The TAIC volunteers will take care of you better than I can take care of you. So goodbye, everybody, and I'll be seeing you later. Thanks.
Good night, everyone.
Thanks, Tim. Check it out.